Hello, everyone. Welcome back to this new series of SSH while we discuss the importance of SSH. Our major topic for today is remote access and file synchronization, but we will be majoring our interest in remote access and SSH. This is because we properly need to understand the importance of SSH and the remote access before we move into file synchronization. Before the end of this class, I expect that every one of us should be able to learn how to access remote systems or servers using SSH, configure key-based authentication for SSH, disallow user root from logging in using SSH, copy files securely between systems, understand the importance of SSH, do SSH password login and passwordless SSH login. Okay. For those of us who are new to this, you may be asking, what is the word authentication? What does it mean? The meaning of authentication is the process of verifying the identity of a user, a device, a process, a server, before we can grant them access, to the resources. For example, before you can access a database server, you need to be authenticated for you to verify who you are, your identity. Once that is identified, you can have access to the server. Now that we've understood what authentication is, let's move to what is SSH. SSH, as we may know it, or for those who are new to this, SSH simply means secure shell. It's a secure way to connect to another computer remotely or another server remotely. It's like having a safe tunnel from your machine into another machine. Okay, and we can have a very simple look at what SSH is soon shortly. From this diagram here, we can see what SSH is all about. SSH helps for security in helping us to transfer data from our local machine to a remote server. Now, this remote server can be a database server, can be a web application server, can be any kind of server. And we are the user trying to access resources in this remote server. It could be files, it could be names of users, it could be password, it could be script, it could be anything we're trying to get from this remote server or from our database server or web application server. It could be anything. But the most typical way for you to understand it is for us to be able to access a file directly from a server, we need SSH. The SSH helps us to create a secure shell or a secure tunnel. It usually opens up on port 22 on both ends. Port 22 on our local server or your local VM or local machine, and port 22 in your cloud server, your remote server, your web application server. It opens up port 22. So when you're asked any day, what is the port number of SSH? You say port 22. Now, it helps for security. All right. So now that we know how SSH work, we need to also understand that for we to be able to use SSH, we need key pairs. You can either log in to your remote server either with the password, we'll see that shortly, or using a key pair. Now, how does a key pair work? A key pair works when we try to generate a type of key pairs. We have different types of encryption. We have the asymmetric and we have the symmetric. For asymmetric, it uses these different keys, the public key and the private key. For symmetric keys, symmetric key pairs or asymmetric or encryption, it uses the same keys for both the encryption and decryption. Okay, now how does this work? When you want to create a key pair for to gain authentication to your web server, you create a public key pair and a private key pair. Now, the public key pair is being copied into the remote server. We'll see that shortly using our SSH copy ID command. And when we do this, the server uses the public key to encrypt and decrypt whatever information we are trying to pass through it. Now, don't forget, there are two ways to log in SSH. You can SSH login with a password or SSH login with a key pair. The key pair is one of the most secure, and that is why we are looking at it today. We will also do the SSH password login so you can see, and also do the SSH key pair. And don't forget, we are using the asymmetric key pair, which uses different keys for encryption. Now that we know the types of key pairs, the type of keys that we have, or the type of key pairs that we have, the type of encryption that we have, the asymmetric encryption and symmetric encryption key pair. Now we need to also understand fully how it works. Like I said earlier, for example, we have a user named Bob. All right. Now Bob wants to send message to Alice here. All right. He says, "Hello, Alice." Now, because a private key pair and a public key pair has been sent across, what happens is this "Hello, Alice" is being encrypted with the public key pair. It sends the data. This is encrypted. You can see from "Hello, Alice," it's encrypted, and we have different random numbers here. Okay, when that is encrypted, nobody can read this. When you see this kind of information, you can't even read it. Alice can't read this information. How does Alice know Bob is trying to say "Hello, Alice"? So for Alice to be able to read this data, she needs the private key to be able to decrypt the information. And when that is being used, she sees the information that says "Hello, Alice." So now that we understand what SSH is and how we can generate key pairs, the key pairs that we're talking about here is the asymmetric encryption, which uses two keys. And also, to bring the message home, we can see that the private key pair uses, it's like your house key. You keep it secret in your computer, and it's usually stored in .ssh /id _ RSA folder. We'll see that shortly. And the public key is like the door lock. You pass it across to the remote server. All right. So we would send the public key, like I said earlier, using the SSH copy ID command, or we can manually do that. So when that is done, it's usually stored within the .ssh /id _ RSA.pub directory. So when that is done, it's important for us to now understand how we can be able to generate an SSH key pair. So we'll be using the command SSH keygen to generate our commands, to generate our key pair. Okay. When this is done, there are different ways for us to generate our key pair. We can use this command, and also we can use the SSH keygen and use a different type, RSA, and give it different number of bits that we want. We can use the 2092048, or we can use the 4096 bits. The B here
is for bits. All right, so can use 2048 bits or can use 4096 bits. Why do we suddenly have bits in this? Now, for we to have bits is the number of time that it would take for an attacker to be able to get the number of passwords before they can be able to gain access to the server. And this is nearly difficult. All right. So this is one of the most secure way. So 2048 is actually secure, but 4096 is much more secure because it will take almost forever to even um you have to try about billions and billions of passwords to get the correct password when you use a 2048 bit. Now imagine when you now use 4096, it's almost nearly impossible because it is because the more bits, the harder it is for hackers to actually break in, but and longer keys take a little more time to use. So that is why we mostly will be using the 2048 because it's a bit less complicated and a bit much more faster compared to when we use 4096. But when you run this command, just because we want to be able to understand what we're saying quickly, this is fine. When you use this, by default, it uses this bit 2048 and it uses this encryption type RSA. Okay, we also have other encryption types. Apart from RSA, we also have the ED25519 and the DSA or the ECDSA SSH key types. All right, there are different types, but this is the most default one when we want to generate our key pairs, the RSA type and the 2408 bit 2048 number of bits. This is the default when we run SSH keygen. So you do not really have to memorize all of this. This is fine because when you run this, it generates this automatically for you. Okay. Now we can ask ourselves that why does the number of bits matter? Why does it matter if we use 2048 bits or we use 4096 bits? Now, because there are a lot of hackers, in the internet, and we do not want them to have access to sensitive information. Now, imagine you have a server that has account details of prominent people in the society like Elon Musk, Bill Gates, and the top guys. They have the account details stored in this server. You want to secure it properly. This attacker may want to gain access to this information. So what this attacker is doing here is trying to brute force the server by trying different passwords. You know, trying to use their username, their age, common things that people use. Though it's been said that most people use password 1234 for their password for their phones, their account details, their emails, and all. People try to use simpler passwords because they want to be able to remember them, but it's very dangerous. You can see Carrie. He was able to gain Carrie because Carrie used her name and her age and her date of birth. This is what most people do. Okay, you wouldn't when an attacker knows the name of a person within a company, they would probably want to use the name in a combination of their age or their daughter's age or people they know's age, to guess the information. So for the number of bits, it will take this attacker billions of years to be able to guess the password because it keeps changing. That is the power of SSH. It's nearly impossible for an attacker to gain access. Well, in the case of brute forcing, this is an example of brute forcing. I won't go too much further into the details because it's beyond the scope of this course. Another very good importance why we use SSH is the man in the middle. It helps to the secure tunnel helps to prevent the man in the middle attack, a brute force attack, and every kind of attack. Now, when this happens, it secures the connection between the two machines. Now, for example, if this man in the middle is trying to sabotage the connection, for example, this man here is trying to access google.com. He comes up and introduces a different web application that looks like google.com, but it's not actually google.com. Now, it is nearly impossible because this user is actually connecting to the web application via a secured tunnel. So, and a man in the middle cannot actually hijack that connection. You may want to look more into detail how man in the middle attack works, but I will stop here for the sake of this course so I don't digress too further away. Okay, now that we are done with that, explain what SSH is and all of that, let's move directly to practice our SSH connection. I have two Ubuntu VM machines here. This was cloned. If you do not know how to clone your VirtualBox Ubuntu machine, please check the previous video where I showed everyone how to clone Ubuntu VM on VirtualBox. All right, so I'm going to start this machine, both of them. So what is going to happen is before I do SSH, it is important for me to know the IP address of my Ubuntu VM and my remote server, and also to know the IP address of my local machine. Don't forget when we cloned the VM, we made our machine to be to have a network setting of bridge adapter. So what this means is that it will be within the same network, the same subnet mask, and within the same network range as our host machine. So if you're using a Windows machine or a MacBook host machine, your VMs will have the same IP range should have the same IP range as your host machine. So I'm going to confirm that once my machine is turned up fully. I'll wait for that to finish. Okay, so we have our VMs running now. So I'm just going to open it up and put in my password. I will do the same for the remote server. So I'll wait for it to finish logging in. And when that is done, I go back to my Ubuntu VM, open it up. This is still coming up. My remote server. This is done. Go to the menu and open up my terminal. Okay, yeah, that is up. Go to my Ubuntu VM. So for the sake of understanding, my Ubuntu VM would be my local server, yeah? Open my Ubuntu VM. Okay, it's finally up. Took a bit of time. We'll also click on the menu and open up the terminal. Okay, so open up my Ubuntu VM again to make sure I'm in the right terminal. Okay, so I'm currently in the right terminal. And to get started, I may want to ping, but before I ping, like I said, our VMs are currently on bridge adapter, and we expect it to be in the same IP address range as our host machine. I am using a Windows host machine or a computer, and I am going to confirm my host password just for us to know exactly how bridge adapter work. Okay, I've explained this in the previous video on how to the easiest way on how to create a virtual machine and how to clone a virtual machine. Check those videos. You will see my explanation on bridge adapter. So to confirm the IP address of my host machine, first of all, I would want to go to PowerShell. So I'll type in PowerShell. I would have to open this. Once it is open, I would type in ipconfig to see my IP address. And from here, I can see my IPv4 address. It says 192.168.1.0.201. I know this is my IP because I'm currently on my Wi-Fi. So and it's within the 255.255.55 subnet mask, which is fine. So this would be my IP range. So I expect my VMs to be within this IP range 192.168.1 dot. So this last value is going to change. It could be 208, it could be 105, it could be 90, it could be 80, it could be anything, but it has to be within this IP address range with the last with the last values changing. Okay, we will be discussing more on IPv4 address and how it works in our networking class. So if you don't understand how IPv4 address work, we would be discussing that in our networking class. So not to digress, we would continue with the rest of our SSH lessons. So I would go back to my Ubuntu VM. I'm currently in my Ubuntu VM machine, and I said I am going to call this my local server. I would check. It's a different command to check for the IP address for your Ubuntu virtual machine. So I use ifconfig, and I can see here that my IP address is 192.168. You can see it's still within the IP address range with a different value here at the last, which is 161. So my full IP address for my local server is 192.168.1.161. I will minimize this, go to my remote server, open it up, type ifconfig, click enter. I can see also that it's still within the same IP address range, which is correct. This is 192.168.1.134. 134. Okay, so we need to take note of this. So my remote server has an IP address of 192.168.1.134, and my Ubuntu VM has 192.168.1.161. And just to confirm, for purpose of correction, you see my host is on 201. All right. So we have same IP address range. So that is the importance of bridge adapter. It shares the same IP address range as your host machine. So let's continue with the rest of our SSH class. Okay, so the next thing we want to do is to ping our remote server. I'm currently my local server. I want to ping my remote server to confirm if there's connection between them. So I will say ping 192.168. I'm currently trying to type in I can't remember the IP address of my remote server, so I will open it up and say show. The last value was 134. I remember the other part. So I'll go back, open up my local server, which is my Ubuntu VM, and type 134. Click enter. I can see there's a connection between them. So let me also, this is my IP address range for my local server, or it's on 161. So I will go to my remote server and also ping from my remote server. I'll ping my local machine and see if there's a connection between both
of the systems. I'll say ping 192.168.1.161. I'm picking my remote server, and I can see, okay, it's still pinging. There's no response yet. Let me go to my local server, open it up. I can see just proper communication between my remote server and my between my remote server and my local machine. So I pinged it. This is the IP address of my remote server. Okay, and I'm having, so to cancel this, I'll press Ctrl C to cancel. I can see I sent 77 packets and I received 77 packets. There was zero loss. What this means is I sent 77 hellos. I received back 77 hellos. There is no any hello lost, and it confirms to me that there's a communication between my Ubuntu local server and my remote server. So let me confirm again if I can connect from my remote server to my Ubuntu VM. So this is still loading. I will cancel this. So it says 100% packet loss. I would have to confirm why that is happening. Okay, a bit of troubleshooting. You would see that I typed in the wrong IP address range. So that is why you need to be careful on the type of IP, or when we're typing the IP address. As you can see here, I mistakenly typed 191 instead of 192. So there is no communication between my remote server and my local server. So it is why it's important for you to check on both servers to make sure there is communication between the both of them, and that the communication is two-way, not just one way. Okay, so I will have to ping my local server once more and say 192.168.1.161. Sorry, I'm typing 191 again. 192. Okay, so I can see proper communication between my remote server. It's communicating directly to my local server IP address, which is 192.168.1.161. I will cancel this. I can see 15 packets is sent, 15 hellos transmitted, and 15 hellos received. There is no packet loss. We would talk about what is happening here underneath when we talk about protocols, TCP connections, and so on, and what ICMP means. I won't progress further because these are all in our networking class. Let's concentrate on just Linux for now. Okay, so when once we've confirmed the communication between the both servers from both ways, from our Ubuntu VM to our remote server, and from our remote server to our Ubuntu VM, there has to be connection both ways from both ends. Okay, so when we have confirmed that, we may now have to check for the user, because when we want to log in via SSH, we need a user. So how do you know who you are? You use the command who am I. I can see I'm currently using the OS boxes user. I would minimize this and go to my remote server and see which user is currently running. Type who am I. I can see I'm also on OS boxes. We can create a user, but we're not going to be doing that today. It's our next topic. We will learn how to create user. We just want to strictly maintain our topic on SSH only. So we would work on the current users that has already been created by default on our systems, which is OS boxes. So I will try to see if I can log in from my local server to my Ubuntu, so to my remote server directly. So let me try that and say, let me clear this. Say SSH. So the user in my remote server is OS boxes at my remote server IP 192.168.1. Just to confirm my remote server IP, scroll up. Okay, it's 134.134. That is the remote server of my remote server. That is the IP address of my remote server, I mean. So I would go back to my local server, which is Ubuntu VM, and say 134. Try to connect. Okay, you can see it's not connecting. There's so many things wrong here. So I'll just cancel. There's no point continuing. I will try to SSH also from my remote server and see if there's any SSH connection already established before now. I'll open and I say, let me call back the IP I used earlier for my local server and just say SSH, because I know that the user in my local server is also same as OS boxes. So I do not have to check which user is currently available there. So OS boxes is the user, and then 192.168.1.161 is the IP address of my local server, which is my Ubuntu VM. Click enter. You can see connection refused. I cannot connect to it because port 22 is currently not open. Okay, so how do we start First of all, we need to now confirm. We need to know if SSH has been installed in this machine. There could be different reasons why this SSH is not working at the moment. It could be that SSH is not installed. It could be that the port is closed, and so many reasons. So, first of all, I may want to confirm and say systemctl status open SSH server. It could not be found, so which means open SSH is currently not installed on my Ubuntu local server. I will go to my remote server, open it up, confirm, clear systemctl status open SSH server is still also not installed, so we have to install SSH in both of the machines. So to do that, I'll say sudo apt install open SSH server -y for yes. Put in my sudo password. I will do the same thing. Okay, wrong error, wrong password. Type in again. Okay, it's currently installing. I also do same for my remote server. Install SSH inside of it. Say sudo apt install open SSH server. Now don't forget I'm using apt because I'm currently running Ubuntu distribution. Okay, for those of us who are using Red Hat, CentOS, this would change. Your package would be yum, not apt. Click on enter. Put in the password. Okay, also wrong. Retry the password. Okay, that is installing. I will confirm my local server, which is on my Ubuntu VM, and see if it's currently at 78%. So we'll wait for this package to be fully installed, then we'll continue. Let's run the command from our Ubuntu VM or local server. So sudo apt install open SSH server. Do the same for our remote server. Run the command sudo apt install open SSH server -y. So we'll see if that is installed. If not, we will have to troubleshoot the problem. Okay, so let's confirm. Well, there's an error in our installation. Let's check the log. Say no space left on device. So this is a volume issue. So we may have to check my disk space. Okay. So here I can see that my boot is almost 78% full. So because of that, it's not able to process my init trams installation processing package. So here we can see how to troubleshoot when you are facing problem for installing any package. Could be SSH, it could be anything. So here df-h, I'm trying to check my disk space. And I can see here it's almost 78% full, which is a problem. There's not enough space, so I may have to delete some things within my machine. Before that, I would confirm also if it's a problem with my remote server. Just log me out, so I'll log back in. Okay, so from what I can see here, it's also fade boot is still the same problem, no space left on device. If I do dfh, I can see also 78% full on my dev SDA file directory. All right, so I may have to delete some things. So I'll just use the auto because I do not want to do too many troubleshooting. So auto remove port any. So this command helps me to delete any unnecessary package that's within my system. Run the same command in my Ubuntu local server. Sudo auto remove -- purge. Okay, so I would see what happens when unnecessary packages within my system is being taken off. We'll try to restore our SSH and we'll see how that is. We'll see what happens after that installation. All right, so this produced another error. So let's see our current running kernel. More troubleshooting. Also do the same for our remote server. Check our current running kernel. Okay. Run one more command. Let's check what's eating up the. Okay. Which folder is that? On the boot. So paste for boot. Okay, so here I'm just checking what's currently eating up the space in my machine. Okay, so here you can see uh, we did uname -r to know the current running version of the kernel that we are currently using is 6.8.0-60 generic. That's the name of the kernel that we're using on our Ubuntu system. And for around this command, sudo ls-lh/boot directory, the boot directory, to see if there's any other running kernel apart from the one I'm having here. And I can see here that I have old version of a kernel running, which is 5.15.0. Can see another one here, 5.15.0, using almost 60 MB. Another one here, 5.15, using almost 6 MB. There's another one here using almost 11 MB. So for me, was using a very little system and very little memory, this is using too much space, and it would save me a lot of effort. When I take this off, I believe I should be able to perfectly install my SSH. So to recap what I just did, um, I had error when I tried to install OpenSSH. I did df-h to check my disk memory, and I saw that within my uh, disk file system, I saw that in the /boot folder is using a whole lot of memory, about 180 MB used, 78% almost gone, and I only have 53 MB available. You can see available here. I've used 180. So what I did is I tried to do auto remove any file, any package that I don't need. I still had an error, so I said, okay, confirm for me the name of my kernel, and I can see my kernel version here. So when I got that, I did sudo ls-lh/boot. The boot is from here, which is eating up my space, to see which other kernel services that are running, which I do not want. And I can see, apart from -60 here, I can see -25, eating up a lot of space, -25, -25, it's a whole lot, -25, eating a lot of space. So I would be taking this off. It's okay I'm having this error, so you can see so that when you also have errors during the course of you practicing the lab, you can have a bit of understanding on how to correct it. So what I'm going to do now is to try to remove this particular kernel. I do not need it. What is it? I don't need it. It's old. It's old. I don't need it. So to take this off, I say sudo. I forget sudo is an admin user. It's a privilege user. So sudo apt remove Linux image 5.15.0 dash 25 dash generic. Okay, let's see if that works. Okay, it's taking off. So I'll say yes. So when this happens, I would do the same thing on my local VM, because it's same error that's happening, and this command should also work for it. But before I do that, I just have to confirm to be sure same problem is what's affecting my local server, which is my Ubuntu VM. I'm currently in my remote server. I can see remote server running here. So that's how I know which which server I'm currently on. While this is running, there's a need for me to probably explain what a kernel is for those who do not have an understanding of what kernel is. So a kernel acts like a middle ground between your computer, between your applications and your core OS, your core operating system services. Don't forget OS, operating system. We have different type. We have MacBook, we have Android, we have Windows, and so many OS. So within this OS or operating systems, they all have a kernel. All right. So the kernel acts as a middleman. It's what does the work. All right. So when you start applications, the application is given a memory, given a CPU, is attached to a device, and all that is the kernel that does all those work on the ground. Okay, so when it comes to calculation, it passes the command to the CPU. Because the memory, it passes the command to the memory. When applications try to do anything, is the kernel that actually passes that information. So it acts as a middle ground. Okay, it acts as a bridge between your computer's hardware and your software. Okay, so of course, we all have our laptops. Our laptops have CPU, have disk, SSD, HDD, and all of that. They can also have flash drives and everything. So, how does our applications, your MS Word, your Ubuntu applications, your every application that you use, how do they communicate with this memory, the CPUs, and all? Is a kernel that actually performs that um, activity for the applications. So, to close this, a kernel is a bridge between your computer's hardware and your software. All applications are software. I believe we all understand what software is. And then our hardware is our hardware, CPU, memory, devices, they're all hardware. For example, CPU, central processor unit, the memory, your disk, hard disk, your flash drives, and all your devices, your keyboard, your mouse, and all that. They're all hardwares. All right, the applications, they are all softwares. So the kernel is the middle person that helps to communicate, that bridges the communication between the hardware and the software. So it's a core component of the OS. Okay, I hope we have a bit of understanding of what OS is. So let's go back. Okay, so when that is done, let me try to fix the package error, the package configure all. Okay, and then let me sudo install. This is just my troubleshooting. Okay, so we have understanding to on how to troubleshoot and correct errors if when we are working on our machine. So I'm going to run this command again in my Ubuntu local server. Okay, Ubuntu VM, open it up. So I may have to confirm which. Okay, I already have my kernel version running, and I know that in my Ubuntu local server, it's also same error, 78% in the boot. So I may also choose to run and list the boot directory to see if everything is the error is the same as what I have in my remote server. Okay, so it's still the same old version that is running. So in case you have this error in your VM, please, this is how to correct it. So now that I know it's same kernel version that is running in my Ubuntu local server, I will now have to delete it. I will run some command as I ran in my remote server. So sudo apt remove Linux image. So 5.15.0 dash 25 dash generic. Okay, I'll say yes. Okay, I think this is complete. I think the first thing I will have to do is first of all to do sudo apt remove auto remove for any other thing left. I didn't run this in my remote server. I may have to go back to run it. Okay, that is done. As I want to just clean it up. Sudo apt clean. Okay, then I would then correct the package that I did earlier in my remote server. Okay, that is done. So sudo apt install -f. Okay, so you can see I did sudo apt install -f. -f here means fix broken, and my dash configure dash or it tells my system to correct any Debian package that I'm trying to install that was not completely installed. So I would try and see to confirm if my OpenSSH has completely status OpenSSH server. Okay, so you can find. So I have to install this. So just a quick recap on what I did. Okay, I ran different commands. First of all, I did df-h to confirm the memory of my disk. Okay, which was this, and I saw you can see that the memory for my boot has reduced to 45%. Okay, um, when we deleted the old kernel. And to confirm the version of my old kernel, I did uname dash r. So uname means Unix name dash r, r for release. So my kernel release version is 6.8 dash 60 generic. All right. So what I did was to list the builds to see if there was any old version. So I will confirm it. I did sudo ls-lh. So what lh mean is give me this in human readable form. I know we are used to listing directories using sudo ls-la. Okay, that is okay, that is fine, but I want it in human readable so that I can see the sizes in terms of um, megabyte. You see df-h, human readable. I'm seeing my file size in megabytes. I can easily look at it and know, oh, I have 250 gig here. I have 128 MB here. I have 197 MB here. Okay, it's easier for me to read. So that's why I'm adding LH. I'm adding a H in my ls here. Okay, I can see that the old kernel is no more there, which is good. So let's try to install OpenSSH again. This has been quite a ride, which is good for those who are just learning this. You can see that 0 upgraded, 0 newly installed, 0 to remove, and 2 sys to not upgraded. So it means my OpenSSH is already in the newest version. It's already installed. When I run this command,
SSH sudo apt the package configure all, and when I run this command, sudo apt install dash f. Okay, so when I run sudo apt install, let me just write it out. Apt install dash f. It helps me to fix every broken the package installations that I was trying to install. Okay, so let me try and start my open SSH and see if that would work. Open SSH server. Let me start it. Okay, ask me for password. All right. I used open SSH. So let me start to do sudo start SSH. Okay, so that is started now. So I'll say sudo status SSH. Okay, I can see it's active, running. It's enabled. So if by any chance you see that your SSH server is disabled, you have to run sudo system call. Let me disable first so I can see what I'm talking about. This enable SSH. Oh, sorry. Disable SSH. Okay, so let me run the command again. Sudo system call status SSH. So we can see it's actively running, but it's disabled, right? So to start it, I would say to enable it, I would say just in case yours is showing disabled. Okay, if it's showing enabled, that is fine. Okay, I'm doing this for those who their SSH service may be showing disabled. So how do you enable it? I have started it, so I'll say I've started it. I've checked the status. It's actively running, but it is disabled. So to enable it, I'll say sudo system call enable SSH. Okay. All right. So that is fine. So I'll check the status again. I can see it's actively running and it is enabled. Okay. So I'll go to my remote server and do the same thing. It has logged me out. I spent too much time in my local server. Boxes. Okay. All right. So let's clear this. Let's check the status of our SSH here. So it's actively running. So the previous mistake I did was I ran open SSH server as a command, so to give me error. So I was supposed to use system call status SSH. Okay, and I can see it's actively running and it is enabled, so I do not have to do anything here. Okay, so what we have to do next, now that we have our SSH installed, we then have to see if we can SSH directly into our our remote server. Okay, I'm currently my remote server, so let me go to my local server and see if I can SSH into my remote server. So to do that, I say SSH. Um, I know definitely the username is OS boxes. Don't forget, I said how do you know the user that you are SSHing with? Just type who am I. For example, if I go to my remote server and I type who am I see it's OS boxes. Okay.
All right, so I'll go back to my local server and let's SSH into the remote server. So what is the IP of my remote server? So I will go back. I can't remember my IP. Let me clear this. I see ifconfig. Let's see the IP. My IP is 192.168.1.134. So I'll go back to my local server, open it up. I say 192.168.1.134. Okay. Okay, so before I run this command, let me do something. Let me clear. Before we run the SSH connection to our remote server, there's a need for us to understand the different folders where our keys, the private and public keys, are usually stored in. I have a simple image here that brings it home. You can see when we within our .ssh directory, we have the known host. So the known host is actually found in our remote server, and we have the authorized keys. So the authorized keys, sorry, I mean the known host is actually found in our local server, which is our Ubuntu VM, your machine, and we have the authorized keys which are saved in the remote server. To repeat this, the known host directory is found in the home or local machine, your local server, which is the client or the user, the person who is generating the SSH key. Okay, it will be saved. It's when you authenticate, it will be you found it in the non-host, and the authorized key, which is the public key, will be sent and stored in the .ssh authorized keys directory in the remote server. Okay, so what I'm going to do here is to try to find the possibility to know no if there's any available key that I probably might have created unknowingly. So I would say the cd into my SSH directory, and I will list it. I see that there are some keys within my machine, so I would have to delete this so that it does not compromise the new key that I'm trying to create. So remove directory -r authorized keys. That means sudo remove. Okay, check ls is gone. Move for known host. Remove for known host.old ls. So it's empty now. I'll check my remote server for the same thing if there's any previous SSH connection between my machine, and delete it so it does not compromise what we are doing at the moment. Okay, so I'll cd into .ssh, do ls. Okay, I see that I still have some keys there, so I would have to remove them. Remove -r authorized. So this is how to remove a directory using the sudo rm-r command. When that is done, I'll also take off the old key, id
rsa.pub, remove the node host, remove node host.old. I'm trying to have a clean system here, so there is no so I know exactly what is working and what's not working when I'm running my SSH. Okay, so remove this one too. Okay, I do ls. I have an empty directory. There's nothing within the directory anymore. So I'll just go back and just keep it there. Do print working directory to know where I am at the moment. I'm in my home OS boxes directory. Okay, I'll go back to my local server, clear this, go back to my home directory, print working directory to see where I am and my home OS boxes directory, which is my user directory, which is fine. So now I can SSH into my remote server and say SSH OS boxes. Now, this is how you can SSH into a remote server using a password. Okay, so what I'm doing right now, I'm trying to SSH into the remote server with using a password. So I'm using the username, the user's name, and the IP address of my remote server. So if your username is John, you use John at. If it's Gabriel, you use Gabriel at. Whatever user that you currently are. Don't forget, I said use who am I to know the current user that is working on the system. Okay, I think it was 134. Click on enter. I'll say yes for um, fingerprint accepting. Put in my password. Okay, you see, I'm now logged in into my remote server. I'm currently logged in into my remote server. So what I've just done here is doing SSH um, authentication with a password. I'm currently in my remote server. How do I know I'm in my remote server? Okay, so let me exit this. Now I am back to my local server. If I do ifconfig, I see that I'm in 161, but this is not so clear. So what I'm going to do is I will change the host name for this to local server so that we know which where and where we are. So host name, Codo, um, let me set host name. I think that's a command. I'm not sure. Set host name, local server. Okay, that was it. So host name now. My host name has changed to local server. Okay, so let me go to my remote server, open it up, check let me clear this first. Check the correct host name. Host name says Oyugebro, so I don't want Oyugebro. I want for clarity of purpose. So what I'm going to do is change the host name using hostname Kodo, set host name, remote server, click enter, confirm the host name now. Okay, my host name says remote server. All right, so we've changed that. Another way to we can also change our host name by editing the etc host file and adding um, remote server into this. Should we do it? Yeah, let's just make it a complete change. So etc host. I'm
sudo and vim iterate. Don't forget, I said during our first topic, I taught us how to edit files, and I taught us how to use vim as also as another method in editing um, a file. So sudo vim. Okay, there's nothing here, which is strange. Um, let me also okay, let me cut it again. Etc host. Okay, let me go back and see. All right, so I'm currently now in my etc host file. So change this to remote. Okay, I have to confirm the exact name of my exact host name. Host name. It says remote server. There's no underscore. Maybe I should just change this host name Kodo set host name. I want it to match my local server name. So remote server. Let's see if that changes. Host name. Okay, it didn't change, so just leave it that way. There's really no too much hassle. Okay, so click on I to edit. So remote server. There is no underscore. I will save it. Semicolon WQ. Exit. Enter. Um, cut it to confirm if my changes was made. Okay, I see that my changes was made. I have my remote server. For those who don't know what this is, 127.0.11, this is an internal IP address that tells it this is me. Whatever is a look back address. Okay, a look back address. We'll talk about this in our networking class. All right, so let's continue. I've changed this. So I didn't change my etc host file in my local server. So let me go back and change it. We're going to host file. Okay, so let me cut it and see hosts. All right, so let me just change it. So I have to use sudo vi. I can either use vi or use vim. It doesn't matter. All right, so etc hosts. All right, click enter to edit. When you do that, so local server with underscore, escape, semicolon, WQ, exit, enter. Cut it to see if our changes is correct. And we have our local server and our host name. Oh, sorry. The underscore didn't was not added in the host name, so it's giving me a complete compound word. So I have to go back and change that. Click on I to insert, delete the semicolon. I mean, yeah, the semicolon. And, write it in, exit, then cut it again to confirm the change was made. Okay, so we have our local server and we have our remote server. So I'm doing this because I want us to be able to differentiate which of the server we are currently running in. Okay, so if I SSH now again into my Ubuntu, into my remote server, because I'm currently in my local server. So uh, 192.168.1.134. Click enter. So this have to log in with the password. Okay, SSH login with the password. Okay, so I'm currently in my remote server. You can see I'm currently in my remote server. This is my remote server. You can see that here. So I've logged in from my local server to my remote server. So from here, I can I can make any changes to this machine, to this server, updates applications, deploy applications, and do whatever changes I want to make. Create a user, integrate and all. So I do not have to keep coming here and opening it up and making changes and all that. I can just SSH directly here and make my changes. Okay, so let me exit it. So now with that, we've learned how to SSH directly to a remote server using a password. So the next one we're going to do is to learn. It's still the same way if you want to connect from your remote server to your local server. It's still the same way. Okay. To keep this video short, we just keep it as this. You can practice it on your own. So we've now learned how to SSH directly to our remote server with a password. Now to be able to, um, this is not so secure because if anybody has password to the password for this, they will be able to access our server. And don't forget, most servers have sensitive information, sensitive credentials, which we don't want a third party to gain access to. So the best way or most secure way to do this is to initiate a passwordless authentication. Don't forget, I said authentication simply means the ability for the server to identify who is actually trying to log in. All right, if the person is a legit person, if the person is authorized to log in. Okay, for example, we are in our phones, we have passwords. So the passwords helps your phone to know the user who is inputting the password actually is the owner. Okay, and by the time somebody else have access to your password and they can open your phone without your permission, and you don't want that, right? So we would rather make it a passwordless login in the sense of maybe using your fingerprint or using your face ID. That is a passwordless login. So for our SSH, we can't use face ID or and all that. But we can use key pairs. Like I said earlier during the course of the video, we have asymmetric encryption key pairs and the symmetric encryption key pairs. We will be working on the asymmetric, which is using different key pairs, the public key pair and the private key pair. So the private key pair is usually stored within your local server, and the public key pair is stored in the remote server. And I showed us that the hosts are usually, and the keys are usually saved within these directories, right? So to create our SSH key pair, let me try this. We use this command SSH keygen. I'm not using the TRSA-D20. Is still the same thing. The number of bits is still the same thing. Just for us to be able to, for the sake of simplicity, we just use SSH keygen. You can see it's now creating our private key and asking us where do we want to save it. So enter file in which to save the key. It's saving in our home OS/6 directory inside the .ssh directory. This is the private key pair, and it's usually saved as ID RSA. So I will leave it as default and click enter. It's asking for a password for it. I do not want it. I just say enter. I say click on enter again. So now automatically it has created both the private key pair and the public key pair. So the public key pair is saved as the ID RSA.pub, the pub for public, and the private key is just the ID underscore RSA. Okay, so to confirm the keys, I would have to log in into my .ssh directory. So I'll say change directory as cd.ssh. So I'm in there, so I will list it. I can see my ID RSA.pub. If you see here, I now have non-host. The non-host is because I have successfully authenticated to my remote server. Okay, don't forget, I'm currently in my local server. You can see. So If I want to cut this, I can see how. Okay, let's cut host. You can see this is the password which has been encrypted that the local server has used to connect to the remote server. Okay, and this is my private key pair, and this is my public key pair that I just created because I did not want to log in with a password anymore. All right, so we are going to transfer this public key pair into our remote server. Why? Because so that the remote server can use this public key to authenticate us, to authenticate our identity, to confirm our identity, to confirm that we are actually the one trying to send information to it. Normally when before you access a door, you need a passcode, right? So what if you do not, you don't, you, what if somebody steals the passcode? You may want to use a face ID, all right, or a fingerprint. So it's still the same thing we're trying to do here. So the public key pair would then be transferred to the remote server. So how are we going to transfer the public key pair to the remote server? We are going to use the SSH copy ID command. When we use the SSH copy ID command, because we also know the username of our remote server that we are trying to push the public key into, we then are going to put in the password and say 192.168.1.134. That is the IP address, sorry, IP address of our remote server. So when I run this command, what happens behind the scene is this is going to connect to our remote server using SSH. When it's connected, it's going to automatically create the ssh.ssh directory if it's not there, usually in the home. Then when that is done, it will create the authorized key that directory. Don't forget, I say the public key is usually stored in the authorized key directory of the .ssh. Okay, so the public key, it will automatically create this directory for us and save the public key inside of this. Okay, all right. So when that has been achieved, we can now, it will now copy the keys into the directory authorized host, and we can now be able to SSH directly into the remote server without a password, which is called passwordless authentication. All right, so I will click enter. So it's asking me for a password. So I will put in the password, my initial password. I see a number of keys added is 1. And it says now try logging into the machine with OS buses 192 and check to make sure that all the keys you wanted were added. So first thing first, I can either go to my OS boxes, right? Go to my remote server and check. Okay, but I'm not going to do that. I'm going to um, SSH directly from my local server into my remote server and confirm if the keys that we sent was actually put in place. Of course, it will be if we successfully SSH into this without a password, then it confirms that we will be successful with our copying the public key into the remote server. Okay, but just for the sake of clarity and for the sake of confirmation, we'll just log in and confirm that the key we transferred is actually there. Okay, so I would call back my command that I ran earlier, SSH OS boxes at 192.168.1.134, and click on enter. You see I am logged in. I didn't put in any password.
So this is passwordless authentication. I'm currently in my remote server without a password. So what happens here is what I explained in the beginning of the video. So it sends a private key, it sends the public key to the remote server. The remote server sends back a feedback to our local server, and it authenticates it. It verifies that information with the private key that it has to decrypt. So what happened is when you say hello, it's encrypted, right? So the hello is decrypted with the public key from the in the remote server. So the remote server sends back an hello. Our local server uses the private key to decrypt that information. So even if a man in the middle attack happens, they can't even see what we are talking about. We can't see the information that we are passing across. We can't see the password or the credentials that we are transferring to each other. Okay, so just to confirm where we are, I'll say host name. You can see I'm a remote server. So most for sake of clarity also, our .ssh folder is always hidden. So it's good to not to use dash l but use dash al or la list all. Would see it here. It's always hidden because if you do ls only, you won't see it. It's hidden, so you won't see the SSH. But I know it's always here, so I don't have to list it when I'm trying to access it. So I'll just change directory .ssh. Okay, I'm in now. I'll do ls. I can see that automatically it created the authorized keys. Don't forget that before I had it, but I had to delete it so that we can know exactly what we're doing and if what we are doing is actually working. And so this is perfect. It created the authorized key for us. So I'm going to cut it and see what is in here. Okay, so you can see um, our key pair, our public key pair, and it has our fingerprint on it. OS bosses at local server. Okay, you see, this is quite interesting. It's a lovely concept, and I would really appreciate us to practice this, go a longer way to practice all of this. So the final thing that we are going to do is to transfer a file from our remote server to from our local server to our remote server. So once again, hostname. This is my remote server. So I'll exit. Okay, say hostname. Oh, sorry, hostname. You can see I am back in my local server. Okay, it's quite interesting. So you see, right now I'm not clicking what remote server, Ubuntu, remote server, local server. I'm no longer clicking back and forth here. Okay, I'm just directly um, doing SSH into the remote server and making my changes that I want and checking and confirming what I'm doing. Okay, so we have a list of files here. Sorry, let me go back, print working directory to see where I am. I'm back in my home directory of the OS buses user. So I'll do ls. Okay, so I am back in my home, my local server. Host name, confirm again. Oh, sorry, host name. I'm back in my local server. So what I'm going to do is to move this england.txt file to my remote server. I'm going to transfer this file, copy this file, and transfer it to my local server. So how will I do that? Simply, you use the scp command, the secure copy command. Secure copy the name of the file, england.txt. So this is how you transfer a file from from your local server to your remote server. So I have a file, sap england.txt, which is the name of the file. So my user, just like what we did earlier, or his bosses, the IP of my remote server, 192.168.1.134, and I click enter. Okay, so that is done. You see, there's no password. Oh, sorry.
Sorry, there's a bit of an error here. I should have inserted the 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 directory, the path where I want my file to be saved into. So this didn't work. So if it didn't work, how do I know it didn't work? Because it is saved somewhere else. You can see instead it created a folder for me here. I mean, it created a new file for me here. Yeah. So it copied this file into this file, and that is not the purpose of what I'm trying to achieve here. Okay. So this is what's going to happen. Before I copy my, let me delete this first. OS boxes. Okay, ls. So it's gone. So ls again. I have my england.txt. So let me cut it. England.txt. Okay, so I have some words into it. It says welcome to London. London is a great city. London is located in England, of which England is a country in Europe. Okay, so let me just add a bit of a word and say echo we love London. Okay. Um, I'm appending it into the England.txt. So this double greater than is telling it that don't delete what is in the file already. Just add this into the file England.txt. Okay. All right. So that is done. So let me cut again. Cut. You can see we love London has been added into our file. So let's move this into the remote server. All right, so we use SCP, name of our file, our remote user name, OS boxes, and the password 192.168.1.134. Then the remote path where we want it to be saved. So home.osboxes, home.osboxes. That's where we want it to be saved. Yeah. So click enter. You can see that one file has been transferred 100%. The size of the file is 8.6 kilobytes per second was sent. So with a list, you can see that we still have the file here in our remote, no, sorry, in our local server. Okay, so let's log in into our remote server and confirm if our file that we sent is in the remote server. So we call back, we SSH into it. Okay, SSH into our remote server. We say we are in, there's no password. This is passwordless login. So let's confirm where we are. We say host name. We are in our remote server. And so let's confirm um, our file. First of all, I say print working directory. Let me see directory where I'm currently in. I see home/os boxes directory. Okay, so which is what I did, which was in the same directory where we sent our file into. So let's confirm if the file is inside. Okay, this is perfect. So you can see England.txt here. So let's cut it. You can see the file we've just created. Okay, this is fantastic. Okay, finally, we are going to edit this file, edit the file, and put it in a folder and send it back to our local server. Okay, so how do we achieve that? So to do that, I'm still in my remote server. Okay, so let me clear this. Confirm again. I'm seeing my remote server. So let's correct our england.txt, or before we correct it, before we edit it rather, let's create a new directory and say make directory country, make directory called country. So we have a new directory here called country. Where is it? Oh, this is it, country, in our remote server. So we cd into country with ls. There's nothing in country. Okay, so let me go back. Ls. So what is going to happen is we are going to move England to our country directory. Okay, so this is just a recap of what we've done before. Okay, I'm trying to merge everything we're learning today with what we've learned in the past. All right, so I'm say print working directory. So I'm now in my home OS boxes. I'm trying to move this into the country directory. Okay, so what I'm going to do is I'll use the move command. So move england.txt to home slash OS boxes slash country. Okay, so when I do ls, I cannot find England anymore in my home OS boxes directory. So when I go into the country directory, when I do ls, I can see my england.txt file. So to confirm that that is the correct file that I'm looking for, I just cut it. You can see it is the correct file that I just moved. And when I do hostname to confirm if we have mistakenly moved away from our remote server, I'm still in my remote server for everyone who is not clear. So what is going to happen now is I'm going to edit my england.txt file. So to do that, I can say echo. What should we impute here? Okay, so let's say the best city in the world. All right, so the best city in the world. So we append it into our england.txt. All right, so let's cut it and confirm. So we've added the best city in the world. So we did this in our remote server. Okay, so we are going to move this. We are going to move this back to our. We're going to move this back to our local server. Okay, so but before we move that back to our local server, I'm going to exit. Should I exit? Mm, okay, let's not exit. Let's just keep it as it is. So let us move. I'm still in my remote server. So clear. Check again. I'm still in my remote server. So what I'm going to do is to move move this file, the england.txt, to my local server. So scp. So to move, okay, let me ls. All right, let me cd back. Okay, now I have my country. My country has my file, england.txt. So I am going to copy this entire folder. Okay, with I'm going to copy this same file. Okay, together with the new directory I just created, and transfer both of the files, the file and the folder, into back to my remote server. Now, don't forget, I transferred the file only from my remote
from my local server. Okay, so I edited it. I edited the iglan.txt file, added more words to it. I moved it into a new folder or a directory. So now I'm going to move that new directory and my edited file back to the local server. Okay, I'm just showing you that you can also move file and directories together. It must not be a file only. You can also move it along with the directory. So to do that, to move a directory, say just copy -r, the name of my directory. Now, because my local server uses the same name as OS boxes, I'll put in the password of my local server 192.168.1.161. I think that is it. So I'm going to put it in the OS boxes directory. So I click enter. So because this is the first time it's asking for a fingerprint, and I say yes, osboxes.org, move, be good. So it has transferred my file to this. Now, if you observe what happened here, it's asking for a password. This is because I did not create a key pair, a private key pair for this to be able to have a passwordless authentication to a local server. So I can only do SSH passwordless from my local server to my remote server. So if I want to have a passwordless authentication from my remote server, I have to also generate a key pair and move the public key pair to the local server. Okay, but I'm not going to do that. I believe you understand the concept. So this file has now been transferred to my local server. So to confirm this, I will exit my remote server. So the connection is closed. I am back to my local server. So when I to confirm this, I say host name. I can see I am in my local server. Print working directory. I am my home /os boxes, which is the same place where I moved the file into. Okay, so when I do ls, I can see that I have my country directory now. So let's move into the country directory. Okay, before I move in, let me show you. This is the old one that we moved earlier, right? You can see this is the old one. Okay, clear. So ls again. This is the new one that we have added into a directory, country. So let's see if the file is inside the directory. So cd country, so ls. So we have the england.txt. So let's cut it. So we can see the new word we added, the best setting in the word. So the folder and directory has been transferred back from the remote server to the local server. Now, if I want to log in back to my remote server, I will log in without a password because I have transferred the public key pair of my local server to my remote server. You see? I'm in, but I cannot do a passwordless login from my remote server to my local server. This is because I have not generated a public key pair that my local server can use to authenticate with my remote server. Okay, I hope this is understanding enough. So what is happening is, so what has just happened is we have our local server here, right? And then we also have, let me use a different, we also have our remote server here. Okay, so we connected to our remote server by creating a key pair. Okay, so this key pair, we transferred the public key pair from here
to our remote server. Okay, so id-rsa dot pub. Okay, we did um we did SSH ID copy, and we moved the key pair. So when we did the SSH key when we did the key pairs, we had two. So we moved this, okay, from our we copied this from our local server to our remote server, right? So this would enable us to do passwordless login. All right. So our remote server here, our remote server here, our remote server here has the public key pair for our local server. Okay. So we can log into the server without using the password. But we didn't create a public key pair. We didn't generate a key pair for our remote server so that we can able to also log in without a password from our remote server to our local server. Okay, I don't think that is needed for now. If you want to experiment that, you can experiment it. This is I believe this concept we've just touched as is enough for us to understand passwordless login and password login. So I'm leaving you with this, that for our local server has a passwordless login. We were able to achieve passwordless login for our local server. Then we use password. We need password for our SSH login from our remote server. So if you want to also incorporate passwordless login from a remote server to your local server, you have to generate a key pair and transfer the public key pair to your local server. Okay, I believe this is clear enough for everyone. If you have a bit of question, you can comment on this video and I would respond, or you can reach out to me privately and I'll respond to you and clear up any doubt that you may have. Okay, I believe we've come to the end of this. I would leave the next time we are going to be having our task for our SSH topic. So just to be able to ensure that we have a full understanding of what we've learned today. This is Gabriel Okom signing out. Live long and prosper. I'll see you in the next one.